Welcome to the deep dive. Today we're heading out, staying relatively close by actually. We're looking at Venus.
Earth's neighbor, yeah. The really hot one.
Exactly. We're going to dig into NASA's upcoming mission, DAVINCI. It sounds, pretty ambitious, trying to really understand our, let's call it our dramatically different twin.
It is ambitious.
Yeah.
And it's significant because, it's been over 40 years since we got a direct look. I mean, right at the surface of Venus.
40 years? Wow.
Yeah. DAVINCI isn't just flying by. It's sending a probe down through that incredibly thick, hot atmosphere.
Right through it. Okay.
So the potential for, just fundamentally new discoveries is huge. And Venus, it's kind of a cautionary tale, too, isn't it, about greenhouse effects?
Absolutely. That runaway greenhouse effect, it makes you think how Earth and Venus, starting maybe similarly, ended up so different.
Exactly. And that's really what DAVINCI is about. Why did Venus turn into this toxic hothouse?
So today, we'll unpack why this mission is such a big deal. We'll look at its goals like understanding those ancient landscapes, the weird tesserae formations.
And the lower atmosphere, yeah. What's actually in it down there?
Did Venus once have oceans? Why did it go so wrong? We're basically getting you the shortcut to understanding this mission before it even launches.
Sounds good. Where should we start? The name itself, maybe? DAVINCI.
Yeah, DAVINCI. It's an acronym, right?
It is. Stands for Deep Atmosphere Venus Investigation of Noble Gases, Chemistry, and Imaging. Quite a mouthful.
Huh, definitely.
But the link to Leonardo da Vinci, that really said something about the spirit behind it. Curiosity, exploration.
So when's it happening?
We're looking at a launch, probably early 2030s. And the cool thing is, its approach, it's got two parts, an orbiter and then that descent probe we mentioned.
That probe feels like the star of the show, really.
In many ways, yes. It's the first probe that will actually travel through the Venusian atmosphere and reach the surface this century.
Right, because the last ones were Soviet missions. Way back.
Way back, yeah. Venera and Vega. And Da Vinci isn't alone in this renewed interest. NASA's also got Veritas. ESA has Envision coming up, too.
Ah, okay. But those are orbiters, studying from above.
Primarily, yes. They'll do fantastic science from orbit, mapping, and radar. But Da Vinci's probe, that gives us the ground truth, the in-the-thick-of-it data.
So what were the sort of limitations of those older Soviet probes that Da Vinci hopes to overcome by going right in?
That's a good point. The Venera and Vega landers were amazing for their time, but, they didn't last long on the surface. It's incredibly hostile down there.
Right, the heat, the pressure.
Exactly. And their atmospheric measurements, while valuable, weren't as detailed or continuous as what Da Vinci aims for. Da Vinci's probe has newer instruments and is designed for a longer journey down, collecting data all the way.
Okay, so this probe takes the plunge. What are the big firsts we're expecting? What makes it so, groundbreaking?
Well, one really exciting thing is exploring a specific type of terrain called tesserae. The target is Alpha Regio.
Tesserae. I've heard that term. They're unique to Venus, aren't they? Like highlands.
Exactly right. Only found on Venus, cover maybe 8% of the surface.
Mm-hmm.
Think of really old, complex, rugged, mountain-like areas on Earth, but Venus style. Radar missions saw them, mapped their shape from orbit, but none of those earlier probes, back from 66 to 85, actually flew over and studied or photographed them during descent.
So radar gave us the outline, but Da Vinci is going to get a much closer look as it flies down over them.
Precisely. A detailed geological look during descent. And the theory, the really exciting theory, is that these tesserae could be ancient continents. Billions of years old, perhaps.
Ancient continents on Venus.
It's possible. And if they are, analyzing them, even from the atmosphere just above, could tell us if Venus had continents like early Earth. And the really big question, oceans.
Oceans, wow. Finding evidence for past oceans would completely change how we see Venus, wouldn't it?
Absolutely. Yeah. It opens up questions about past habitability, even if it's inhospitable now. Water shapes everything on a rocky planet. So finding signs of water locked in those tesserae rocks, that would be huge.
And it's not just instruments sniffing the air, right? You mentioned imaging. We're actually going to see this terrain.
Yes, actual pictures. The probe has infrared and optical cameras. These will be the first close-up views of Alpha Regio, the first surface photos in, over 40 years.
40 years, that's incredible, especially given how tough it is to see the surface.
It really is. You've got surface temperatures around 900 degrees Fahrenheit, pressure 90 times Earth's. And that atmosphere is just opaque. You can't see through it easily from space, not invisible light anyway.
Yeah.
That's why we rely so much on radar.
So radar kind of pierces the clouds, but it's not like seeing it with your eyes.
Exactly. DAVINCI's probe drops below the main cloud decks. It's underneath the thickest layers to get a clearer view downwards. They've compared the expected quality to looking out an airplane window as you're coming in to land.
Okay, that gives a good sense of the detail. So what are scientists hoping to spot in those images? Specific things that might hint at past water.
They'll be looking for geological clues, things like layered rocks that might suggest sediments laid down in water, or maybe features that look like old shorelines. The images will help build these really detailed 3D maps.
Wow, 3D maps, that's much more than just a snapshot.
Much more. Allows for really in-depth analysis of the terrain, trying to spot minerals or rock types associated with water.
Okay, so that's the surface and the tesserae. But you also mentioned the atmosphere itself, especially the lower part. Why is that region so important?
Yeah, the lower atmosphere, below the main clouds, it's like a reservoir of information. It holds gases that could be coming up from the surface, maybe from volcanoes, or reacting lower down.
Stuff we can't really measure well from orbit.
Right, and DAVINCI will be the first mission to measure the chemistry continuously as it descends through this region, from about, say, 90,000 feet down, almost to impact.
So not just snapshots here and there, but a whole profile.
Exactly. Like drilling an atmospheric core sample. It lets us see how the composition changes with altitude, which can point to where different gases are coming from.
Okay, so what kind of secrets might be down there? What gases are they really keen to find?
Well, for instance, sulfur compounds. Finding certain ones or specific amounts could be a strong indicator of active volcanism, or at least very recent activity.
Volcanoes on Venus now. That would be huge.
It would. Then there are the noble gases, helium, neon, argon, xenon.
Ah, the unreactive ones?
Exactly. Because they don't really react chemically, they're amounts, especially the different isotopes, are like fossils. They tell us about the very early atmosphere, how Venus formed, and critically, about its water history.
How much water it started with, maybe?
Potentially, yes. And comparing Venus's noble gas signature to Earth's and Mars's, that's fundamental to understanding why these planets turned out so differently.
That whole comparative planetology thing. Why did Earth stay wet and Venus become, well, Venus?
That's the billion-dollar question, isn't it?
Right.
DAVINCI will also look at isotopes of other elements, like hydrogen and water vapor, to trace how water has been lost over time.
Which ties back into understanding that runaway greenhouse effect.
Absolutely. It's all connected. Understanding Venus's extreme climate helps us model climate processes in general, even here on Earth.
It sounds incredibly challenging, though, surviving that descent. What kind of tech makes this possible?
Oh, the technology is definitely cutting edge. The probe itself is basically a pressure vessel wrapped in some serious insulation.
Like a thermos.
A very, very high-tech thermos, yeah. Multi-layer insulation, advanced ceramics, silica fabrics, aluminum sheets, designed to withstand that incredible heat for the duration of the descent.
And slowing down, that dense atmosphere must help, but it must be complicated.
It is. The atmosphere provides a lot of drag, which helps slow the probe down naturally. But there's also a parachute.
Okay, a parachute.
But not just any parachute. Think about those clouds that are made of sulfuric acid.
Ah, so a normal parachute, like nylon?
Would just dissolve, yeah.
Mm-hmm.
So this parachute has to be made of an acid-resistant material. The material they're using is apparently 5 times stronger than steel by weight.
Wow. Stronger than steel and acid-proof. That's some serious material science.
It really highlights the unique challenges Venus throws at you. Everything has to be custom-built for that environment.
So, who's pulling all this together? Which part of NASA is running the show?
The lead center is NASA's Goddard Space Flight Center. That's in Greenbelt, Maryland.
Goddard, okay.
They're handling the overall project management, the science leadership, the systems engineering, and they're actually building the probe itself.
And the science team? Are they all at Goddard?
No, it's a diverse team, researchers from universities and institutions across the U.S., and the spacecraft part, the orbiter that carries the probe and relays data. That's being built by Lockheed Martin Space out in Denver.
Okay, so Goddard manages, Lockheed builds the bus, and the science comes from all over.
Pretty much. And the whole thing falls under NASA's Discovery Program. That's managed by Marshall Space Flight Center for the Main Science Mission Director at NASA HQ.
Got it. A big collaborative effort then.
Definitely. Takes a village to send a probe to Venus.
So just to kind of wrap our heads around the big picture again, it's about Venus's history, right? Yeah. How its climate went off the rails and whether it could have ever maybe supported life.
That's the core of it, yes. Using atmospheric sampling and those high-resolution images of the tesserae to piece together that history.
It really feels like a pivotal mission for understanding Venus.
It absolutely is. Directly sampling that deep atmosphere, getting those close-up terrain views, These are things we haven't done in decades or ever in this kind of detail for the tesserae. It could genuinely reshape how we think about Venus and maybe how rocky planets evolve in general.
So for you listening, this isn't just about some distant hellish planet. It's about understanding our own place, maybe.
I think so. Venus is like this extreme natural experiment. Seeing how its climate ran away, understanding the geology, it has lessons for us about planetary climate, planetary evolution, maybe even the conditions needed for life elsewhere.
Absolutely. So as we wrap up this deep dive, maybe something for you to think about. When we get this detailed data back from DAVINCI about Venus's runaway greenhouse effect, how might that really sharpen our understanding of Earth's own climate challenges?
And could those ancient tesserae, if they really are old continents perhaps formed with water, change how we search for habitable worlds beyond our solar system? What signs should we look for?
Lots to think about. DAVINCI is definitely poised to give us some critical pieces of that puzzle. Thanks for joining us on this deep dive.